Don't crash. Oh, you didn't crash. Did not crash. Okay, let's get to number 2. All right, everyone. Welcome to the wonderful after school. We are going to try to... Wow, the lag is killing me here. All right. We're going to try and get out of here. Do this as... maybe not as quickly as possible, but we are going to try to make this so we're not here all day. So we got cosine squared y sine x. Oh my gosh, me sneezing. Okay, first step, you're going to separate variables, and you're going to have dy over cosine squared y equals sine x dx, cosine squared, yeah. And the thing to realize about this one is 1 over cosine, that's equal to secant. So, in other words, what I'm trying to say is the left side here, that's actually secant squared y. Which is nice because now we have an antiderivative for secant squared. That's an ugly one. That's a little better. All right, so the antiderivative of secant squared, I think you see it on the board behind me. It's tangent. So this is tangent y. We're going to put the c on the right side of the equal sign. Antiderivative of sine is negative cosine. And of course that constant. And now the question is, how do I get the tangent to get, how do I get the y out of the tangent? And of course the answer is to use an arctangent. So we're going to use an arctangent on the left side and an arctangent on the right side. So the left side is the arctangent of tangent y equals the arctangent of negative cosine x plus constant. Okay, the arctangent of the tangent of y is y. Tangent and arctangent by definition are inverse operations. And y is going to be equal to the inverse tangent of, well, it's probably nicer to see it as c minus cosine x. Notice that not all antiderivatives have a plus c at the end. The c ends up in surprising places depending on the complexity of the integral. Moving on to 3. Delicious, delicious cake. Instant that a cake is removed from an oven, the temperature is 380. After 10 minutes, the cake is 250. Wow, that's... Okay. The temperature of the room is 75 degrees Fahrenheit. How much longer until the cake is 90 degrees? Round your answer to the nearest 5 minutes. All right, so let's write down our equation first. This is a Newton's law of cooling method. So the temperature with respect to time is equal to the Ts plus T naught minus Ts e to the... Now, is it negative KT or KT? I forgot what you guys did. Negative KT? Negative KT. Ooh, running out of batteries. Oh, is it?
Yeah. Isn't it T minus TS equals T naught minus T? Yeah, that's what it says in
Oh, that's the same thing as this formula. If I subtract the TS from both sides, it's the same thing. Okay. Let's get the variables that we know. We know TS is 75 degrees. We know the initial temperature of the cake was 380 degrees. And we know that the temperature at time equals at 10 is 250. Those are the three things that are given to us. We should be able to cobble together an equation. Okay. So we have T equals 75 plus, 380 minus 75 e to the negative kt. T of t equals 75 plus, is that 305? E to the negative kt. Let's go ahead and get ourselves a, use our initial T10 is equal to 250, and that's equal to 75 plus 305 e to the negative 10k. Okay. That second temperature reading, the one that's not initial, you're going to use to find k. All right. Is that 175? 175 over 305 is equal to e to the negative 10k. Okay. Negative 10k is equal to the natural log of 175 over 305. K is equal to negative 1/10 natural log of 175 over 305, which is equal to, time to grab the calculator. Yeah, I'm going to actually do it on the calculators. Thank you for that, though. Uh, 1/10. Ooh, I forgot the negative sign. Negative 1/10 natural log 175 over 305. Did I get that right? Okay. And that's going to be my value of k, 0.055. Okay, I'm writing that, but I'm not actually going to use that for anything. Okay, because the question now is going to be, when is the cake going to cool to 90 degrees? So, what is the temperature going to be at 90 degrees? So that's going to be 75 plus 305 e to the negative kt. Notice that I'm not actually putting the number there for k. I'm just putting k. K now stands for 0.055. It's the constant proportionality from the differential equation. Okay, we're going to go ahead and keep solving here. 90 minus 75, 15. So we have 15 over 305 equals e to the negative kt. Remember, k is already a constant that we know the value for. K is 0.55. Okay. That means that negative kt equals the natural log of 15 over 305. And finally, t is equal to negative 1 over k natural log of 15 over 305. Let's go to the calculator. Get a number here. We have negative fraction 1 over, okay, so the cursor is in the place where I'm going to paste, so I'm just going to scroll up, push enter, and that'll paste that.
Wait, yeah, so that's what happened with me.
Oh,
Should we
Yeah,
just,
see, you
why
can
don't we
do
just
that.
store it as K?
you want to do that?
Yeah, that works.
Yeah, you can do that.
Oh yeah. That's smart.
Negative 1 over, yeah, that's a good idea. Answer, why not? 1 over the answer. Natural log of 15 over 305. Yeah, that works for me. 54.223.
Would it be 4?
So they want to subtract it.
All right, they want you to. Wait, so hang on. How much longer, right? So currently, t equals 10, right? Therefore, the cake will be cooled to 90 degrees after 44.223. Remember, we're already at t equals 10. They were saying, how much more time will it take? Are we rounding to the nearest 5 minutes? Or
No, because it's 54 minus 10.
would be 45 minutes approximately. That looks like a bad grammar.
So the answer's 50.
Yeah, I think I messed up with the 10 degrees, or the 10 minutes in the answer key. Okay. It's pretty good for a question number 3. Let's take a look at question number 4. Actually, do you have any questions on that? Question 4. At the instant the decay equation for a radioactive element is y equals y naught e to the negative 0.16 t, where t represents years. Okay, so you have to get used to this. They're using different variables for their constants. Question A. What is the initial, what is the half-life of the element? Half-life of the element. Okay, so do you remember the equation here? No. Okay, so 1 over half-life times the natural log of 0.5 is equal to K, isn't it?
Just the symbol of half.
Tau? But the video game. No? Tau. Fine, we'll use tau.
That's a symbol.
1/2. It's nowhere near as fun as lambda. That's what I'm saying. All right. I just want to make sure I got this formula right. Is that right? Natural log of 1/2 over half-life.
Yeah.
Someone want to check their notes?
Do you have to do it this way, or can you do it with like why not?
You could completely solve it out. Yeah. All right. So what do we got? K is negative 0.16, right? Negative 0.16. So in other words, what we're saying is tau 1/2 is equal to K over, natural log of 0.5 over negative 0.16. Okay, calculator time.
Is that the same as natural log of 2 over half? That's what the book is.
No, it's not.
Is half-life equals natural log of 2 over k?
Natural log of 2 over K. Oh, you know what? It's no, I don't know what do we have in the notes?
That's what I have in the I got that from the book.
I know. I think. Solve it the long way. Yeah, we'll do the long way as well. How about that? That's what we have in our notes. Okay. So we have the natural log of 0.5. Where's my cursor?
It's on the down arrow.
Okay, so the natural log of... Wait, what's going on? Oh my gosh. Oh. Whoa.
Should be.
Natural log of 0.5 divided by negative 0.16. 4.332 years.
Yeah.
Yeah.
Equals 4 point... We were talking about doing this the long way, and there's no problem there. We're actually just going to get to this equation anyways. So the way to get that is, at the half-life, the quantity is half of y naught, right? At the half-life?
Yes.
When t equals the half-life. Well, we should make that tau 1/2, right? And so you end up getting 1/2 equals e to the negative 0.16 tau. That means the natural log of 0.5 equals negative 0.16 tau 1/2. And it's the same thing, right? Tau 1/2 equals the natural log of 0.5 divided by negative 0.16. So it is the same formula. If you don't want to learn the additional formula, then you can absolutely just go right to basics and figure it out from there.
It's always 0.5.
Always 0.5 for half-life. I know. We need the reassurance. I understand. I've been doing this a long time. I'm having a lethal moment weapon, or lethal weapon moment, where I'm sitting on the toilet. I'm getting too old for this shit.
Wait, what?
Did you ever watch Lethal Weapon?
Oh, I thought you meant like you had a moment where you're sitting on the toilet like
No,
I wish
no.
I had a lethal weapon to kill people
No, oh my God, no. I'm a pacifist.
I think that sounds
I was quite confused about what you were going with that.
I am a.
Now
We're
it's on the
we're
recording.
just gonna have to watch
Don't incriminate
Lethal
me.
Let's
Weapon.
just watch Lethal Weapon.
How long will it take for a sample to decay 66% of its original? All right, so when is it going to be 66 of its original? My gosh. There we go. Okay. So 66%, that means 0.66 y naught is the amount. 0.66 y naught equals y naught e to the negative 0.16 t. Let's just go ahead and look into the future a little bit. That's going to be the natural log of 0.66 equals e to the negative 0.16 t. That's a t, not a tau. Ooh, please, with the shoes.
If we found the natural log, why do we need it? Why do we still have to do that?
Oh, the e should be dropped. Yeah, you're right.
I thought I was
You're right.
saying something.
Negative 0.16 t.
Yeah.
And so t would be equal to negative natural log of 0.66 over 0.16. Man, aren't we lucky we didn't do mathematics at the turn of the century? None of this would have been so much more difficult. We got negative natural log 0.66 divided by 0.16. Good. 2.596. 2.596.
597.
597 would be accepted. Okay. That's B. How are we doing on exponential decay? Not a lot to it? You got this?
Miss Correa, which questions or question is going to be our FRQ?
I can't tell you which one's going to be the FRQ. I can point you to the longer ones with multiple parts.
Gotcha.
That's a pretty good indication usually.
Would this one be included in the
2 parts, yeah, possible. Okay, moving on to number 5. Another Newton's law of cooling. I'm so glad that we watched that video on Newton's law of cooling. Let me tell you.
Okay.
8, 9.
We never
There's,
did it.
there's no way.
Okay.
When t equals 12, good. So we're going to go through this. I'm probably going to just do the problem as I think it's going to go. It's lovely. They gave you all the values of the constants. Now they don't give you the actual equation. That's too bad.
We know that.
TFT equals
There we go. Let's plug things in. TT 72 plus 190 minus 72 e to the negative kt. We're going to plug in now. T of 12 is equal to 120. And that's going to be equal to 72 plus 128, 118. E to the negative 12k. And we're going to get our value of k out of this. 120 minus 72, it's 20 plus 18, so 38.
48.
48 over 118 equals e to the negative 12k. Negative 12k equals the natural log of 48 out of 118. K equals, let's go ahead and do this, negative 1/12. You getting tired of that fraction key?
Yeah.
I am too. Negative 1/12. Natural log of
48 over 118.
48 out of 118. Just make sure that when you decide to use a division instead of a fraction bar, just make sure you put parentheses in more places than you think you need it. Okay? Entire numerators need to be in parentheses. Entire denominators need to be in parentheses. Don't make an algebra mistake. Your calculator knows the order of operations and expects you to use them. Okay? K equals 0.749. I think someone was very wise and said, why don't we store that?
It's 074. 074.
Sure. Let's store that as K. That's not a bad idea. K equals negative 0.74.
Wait, it's not negative.
No, it's not negative. It's positive. You're right. 0.704. 0.74. Wow, my brain is not
Teachers
not
meetings.
cool.
Meetings.
Okay, that's our value of K. What's the temperature when T equals 25? T 25. This is nice because this is straight. Put the number in the calculator. Let it do its thing. There's not a lot to do with part B. Just go ahead and put it in your calculator. Let's put it in our calculator. 75 plus
Wait, 72.
72.
Yeah.
Yeah.
I mean,
118, like the freeway. E to the negative, is it 25k? 25k. Since I stored k in my calculator, I can just put the k there, right?
oh yeah. I should have done that.
90,115.
That's just what it is.
Be smart about your calculator. C. When will the temperature be 85 degrees? I don't know. It's a good question. You just need to make sure you can solve an exponential equation like this. Let's see. 8 plus 5 is 13. So we have 13 over 118.
You plugged in 25 and it's supposed to be T because we're looking for the time.
Wait, what?
We're looking for T.
Now we're looking for
Already
T,
have T.
but you plugged in negative 25 for the previous equation.
Wait, hold on.
Where is C?
Are you doing C or are we doing?
We're doing
Oh, we're doing. You're talking about C.
Yeah, what do we?
Oh, yeah, right. That's negative KT.
Yeah.
So confused.
KT. Thanks. I totally messed that one up. That should be negative KT. Okay,
We store K.
that's right. Yeah. So
I took this.
negative KT
You know, click store.
equals a natural log of 113. No. 13 over 118. So T equals negative 1 over K, natural log of 13 over 118. T equals, let's do this,
Again.
negative 1 over K. Natural log of, I forgot,
13 over 118.
13 over 118. Take a quick second to make sure I did put all the parentheses correct in the calculator.
Yes, you did.
Make sure that negative sign is not a minus sign. I think it is. 29.426.
I
29.426.
like to call it shit for
It's the longer ones.
All right, that's 5.
I'm gonna have to leave.
All right, 6 is a challenge. No calculator. Ooh, no calculator.
and I don't know her.
That is a sin. Sign.
Find the partial fraction decomposition. Find the antiderivative. Find the average value. Whoa. Hey, buddy.
What's average value?
Eliza. For average value.
I don't remember.
5 over
T squared.
t minus
T squared.
t minus 5 t plus 2.
What do you do?
T minus. Yeah, T minus 1.
Oh, okay.
Plus 2 equals a over. Remember, put the minus 1 first. That'll help you out with the minus and positive signs. Equate the numerators. Let me clarify. It doesn't matter which one you put first, but putting the negative one first is a better idea. The positives and negatives usually work out better that way. You don't have to. You know, you can put it in any order you want, but in my experience, this works out better. All right, let's pick values of t. What do you think?
5.
Good. You guys are learning. I like that.
You figure that out.
You want to make one of them 0.
Well, you want to stop.
Got it.
Okay, and then the other one?
-2.
Good. And look, it worked out again. The positive and the negative. B became negative. A worked out to be positive. It's like magic. It's like I know what's going to happen. Oh, wait, I do know what's going to happen.
Wait. Okay. It's fair.
Yeah.
So you plug in the t equals 5 into the other one, right? Not the one where it would make 0, but the other one.
You plug it into both. Because, but yeah, when you plug in 5 here, you're going to get a 0.
Oh, okay.
You know, I think you guys are smart enough not to know that 0 times b is 0.
Okay.
All right, let's start with the equation. The equation of equality. Our equality is 5 over t squared minus 3t minus 10. That's equal to 5/7 over t minus 5 minus 5/7 over t plus 2. Remember, this line right here is the exact same thing as the line that we started off with. I'm just filling in the blanks for A and B. Next step, I'm going to take that equality and I'm going to integrate both sides of the equality. Because whatever you do to the left side, you should do to the right side. Yeah, I think this was part A right here, right? That's part A. Part B, t squared minus 3t minus 10 equals the antiderivative of, well, I'm going to be really smart and factor out the 5/7 now. Okay. Okay, now I'm only going to be working on the right side. 5/7, of course, is constant. Make sure you do your u substitution. U equals t minus 5. du equals dt. So I don't need to worry about any constants, any negative signs. I can just integrate like normal. That's the natural log of the absolute value t minus 7. T minus 5. All right, u equals t plus 2. du equals dt. So I don't have to worry about negatives or constants. This is minus the natural log of t plus 2 plus constant. Okay, let's put everything on top of each other, and we're going to say this is 5/7 the natural log of t minus 5 over t plus 2 plus constant. And I think I'm just going to leave it like that.
We're not going to put it to the power.
Yeah.
How come they didn't boil on top of each other?
It's a rule.
And what I'm saying is, the reason why I'm not doing it is, even if I made that a power, I wouldn't get rid of that natural log. I mean, I wouldn't get rid of the absolute values, would I?
No.
I wouldn't.
What did you say we do if we have to add them together? Like it's natural log of the absolute value of 2 minus 5 plus natural log of 2 plus 2.
It would be natural log of the absolute value, t minus 5 times t plus 2.
It's the natural log of what?
T minus 5 times t plus 2.
Oh, okay.
Okay, last part, C. Find the average value from 0 to 10. 0 to 10? 0 to 1. Okay, so the average is equal to 1 over 1 minus 0, integral from 0 to 1 of 5 over t squared minus 3t minus 10 dt. And what's nice about that is you already know the antiderivative, so you can just use the methods of antiderivatives. Equals 1 over 1 natural log of t minus 5 over t plus 2 from, oops, I forgot the 5/7, from 0 to 1. And that's equal to 5/7 the natural log of 1 minus 5 over 1 plus 2 minus the natural log of 0 minus 5 over 0 plus 2 let's see, is this 4/3?
Well, it's negative with the absolute value. The absolute value.
Minus the natural log of 5/2. Oh, look at this. Isn't this 5/7 the natural log of 4/3 over 5/7? 5/2?
Which is 8 over 15.
Yeah, 8 over 15.
Does this look like a free response?
My gosh. That's beautiful. That's my average value.
Oh, we don't have to solve for the natural log.
No calculator.
Oh, right. If we did, then we would have it, right?
Couple more partial fractions.
Okay, I have to go.
I agree.
I want to stay longer.
7. I know you guys are getting kind of crazy here, so come on. 1 over minus x over 2x plus x 2x plus 1. That's equal to a over x plus b over 2x plus 1. Bye-bye.
Good day, everyone.
Okay, we're going to deal with the numerators. 1 minus x equals 2x plus 1a plus xb. Give me a value for x.
Yeah.
Negative x. Negative 1.
Wait.
0.
0.
Wait. Yeah.
Good. 1 minus 0 equals 1a.
Yes.
A equals 1.
Yes.
Give me another value for
B becomes 0. Negative 1/2.
negative 1/2.
Damn it, Brian.
Okay. So 1 minus negative 1/2 is 3 halves. Alright, so what do we have? We have 3 halves divided by negative 1/2. That's like 3 halves times negative 2.
Negative 3.
So negative 3. Oh, hey, look at this. A and B are not the same number.
So now what?
Woo.
Yeah.
Alright, so we're done. 1 minus x over 2x squared plus x equals 1 over x minus 3 over 2x plus 1. That's number 7. Yeah, B is just, or number 7 is just find the partial fraction decomposition.
Everybody's like,
We all see
Number 8, however,
Remember, you have to find the integral.
yeah, 8, you're going to have to find the integral. The ocho. Let's do our partial fraction decomposition. 2 over x plus 2, 2 minus x. equals a over. What do you think I should put first here?
Minus X.
2 minus x
Yes.
Yes, you say minus first.
plus b over
X plus
X.
x plus 2. Gosh, I hope you guys are right.
We hope we are right.
Well, really, we shouldn't make it to be wrong because then that's just.
No, wait, no, because like there's that.
Wait, but there.
Well, I mean,
No, wait.
is it wrong? No, it doesn't matter
It
though.
makes no difference.
It shouldn't.
Yeah,
It
we
shouldn't
just
matter.
guys get rebels.
This is algebra. It doesn't matter. As long as you can reason correctly, it won't matter what order you do it in. Give me a value for x. X equals 2. I like your choice. 2 equals 4a. A equals 1 half.
X equals negative 2.
X equals negative 2.
Now we are.
Yes.
2 equals 0a 4b.
Oh gosh, shut up, please.
They're both 1/2.
Okay. So we're good. We have 2 over x squared. No, it's just like that, right? X plus 2. X minus 2 equals. Well, I can now factor the 1 half. Well, should I factor? No, I'm not going to factor the 1 half. 1 half over 2 minus x plus 1 half over x plus 2.
Oh, wait, X plus 2. Wait,
Huh.
is this supposed to be 2 minus x?
Yeah, on the left
On
side.
the left? X plus 2 and then 2 minus x.
Oh, okay.
Oh.
That got me so confused.
I'm confused.
My bad.
Like so.
Alright, is that good? Okay, what are we doing next? Oh, we're integrating, right?
9. Oh.
No, we're not add natural log, we're integrating.
No, you had no. I'm not. We're not there.
I'm gonna factor out the 1 half. Now I hope that's okay. Okay, now we just have to work on the right side. Equals. Get that 1 half. Be very careful. What's du?
Negative dx.
Sorry, u is 2 minus x. Du is
-1.
negative dx. So this is actually negative natural log of 2 minus x. Okay. Once again, u is 2 minus x. So du is negative dx. Plus. Okay, that's just a natural log of x plus 2, right?
Yeah.
Plus constant. Okay, well, looks like we have to switch the order here, right?
Yeah.
Yeah, yes.
So that is 1 half the natural log of x plus 2 over 2 minus x plus constant. If I use the square root, do I get to get rid of the absolute value?
Yeah.
Yes, I do. crossing this off my list.
Of what? A problem for you to put in such.
Okay, so what's left? 9 and 10 we're going to look at in class tomorrow.
Yeah. Yeah.
You did so early.
I know, we did that so quick.
How many questions are gonna be on that?
I think it's 6 multiple choice, 3 free response.
Damn,
So you're waiting for your
So
response.
it's going to go backwards the way we did last time.
60-40 again? Oh, 35.
We did 35-65.
So it's gonna be 50-50.
35-65.
Oh, so first one